Hello everyone, my name is Abdurrahman Askar, Civil Engineering Department, and my topic is concrete admixtures. Concrete admixtures enhance the properties of concrete for applications in construction with special requirements and used to achieve desired workability in case of low water cement ratio, enhance sitting time of concrete for long distance transportation of concrete, produce high strength concrete. Concrete admixtures is defined as a material other than water, aggregates, and hydraulic cement and fiber reinforcement used as an ingredient of concrete or mortar and added to the batch immediately before or during its mixing to modify one or more of the properties of concrete in the plastic state or hardened state. Reasons for using admixtures: improving fresh state properties, workability of concrete, and improving hardened state properties, strength and durability of concrete, and for economy. Considerations and precautions in use of admixtures. An admixtures is not a remedy for poor mix design and bad concrete practice. Admixtures should conform the standards. Careful attention should be given to the instructions provided by manufacturers. The manufacturer's instructions regarding the dosage of the admixtures to be used are very valuable. Admixtures can affect more than one property of concrete. Besides the technical aspects, economical aspects should also be considered. When concrete admixtures used, concrete admixtures used when properties cannot be made by varying the composition of basic material to produce desired effect more economically, unlikely to make a poor concrete better, not a substitute for good concrete practice. Required dose must be carefully determined and administered. How to use concrete admixtures? Check job specification. Use the correct admixture. Never use one from an unmarked container. Keep containers closed to avoid accidental contamination. Add the correct dosage. Avoid adding a little bit extra. Use a dispenser. Wash thoroughly at the end of the day. Best if added to the mixing water. Manufacturers' recommended dosage is usually adequate. Trial mixes are important to determine most effective dosage. Types of admixtures as per American Concrete Institute Committee report: accelerating admixtures, retarding admixtures, water reducing and set controlling admixtures, air entraining admixtures, superplasticizing admixtures, admixtures for flow concrete, miscellaneous admixtures. Air entraining admixtures, these are generally used to improve workability, ease of placing, increasing durability, better resistance to frost action, and reduction in bleeding. Properties of air entraining admixtures. These are foaming agents, gas-producing chemicals. It introduces millions of tiny, stable bubbles of uniform size that are uniformly distributed throughout the mix, usually about 5% of the volume. Improves property of fresh concrete such as workability, cohesion, and reduces segregation and bleeding. Improves properties of hardened concrete, for every 1% of air, there is a 4% loss in strength, which is minimized by the reduction in water content. It improves durability of hardened concrete. Accelerating admixtures are used for quicker setting times of concrete. It provides higher early strength development is freshly cast concrete. Main uses of accelerating concrete admixtures. These admixtures are suitable for concreting in winter conditions during any emergency repair work in case of early removal of formwork. Disadvantages of accelerating concrete admixtures. It has increased drying shrinkage. It offers reduced resistance to sulfate attack and calcium chloride, high risk of corrosion of steel, not permitted in reinforced concrete. It is more expensive and less effective. Applications of water reducing concrete admixtures. The application of the type of admixtures are as follow. When concrete pores are retracted due to either congested reinforcement or these sections, when harsh mixes are experienced, such as those produced with aggregates, then considerable improvement in the plastic properties of concrete can be obtained. When required strengths are difficult to obtain within specified maximum cement content and where early lifting strengths are required. By addition of these admixtures in concrete cement, economies of about 10% can be obtained. Retarding concrete admixtures. The function of retarding concrete admixtures is to delay or extend the setting time of cement paste in concrete. These are helpful for concrete that has to be transported to long distance in transit mixers and helpful in placing the concrete at high temperatures, especially used as growing admixtures and water reducers results in increase of strength and durability. Why retarding concrete admixtures are used? To delay in the setting time of concrete without adversely affecting the subsequent strength development. Superplasticizers or high-range water-reducing admixtures in concrete. These are the second-generation admixtures and also called as superplasticizers. These are synthetic chemical products made from organic sulfonates of type RSO3, where R is complex organic group of higher molecular weight produced under carefully controlled conditions. Why superplasticizer admixtures are used? These admixtures increases the workability, typically by raising the slump flow from 75 mm to 200 mm in the production of concrete of normal workability but with an extreme high strength. Superplasticizer can reduce the water content for a given workability by 25 to 35% compared with half that value in the case of conventional water reducing admixtures. Advantages of superplasticizer admixtures. The concrete using these admixtures can be placed with little or no compaction. They do not influence shrinkage, creep modulus of elasticity, or resistance to freezing to thawing. Disadvantage. The only real disadvantage of superplasticizer is their relatively high cost. Applications of superplasticizer admixtures in very heavily reinforced sections in inaccessible areas in floor or road slabs where very rapid placing is desired. The second type of admixtures is mineral admixtures for concrete. We have two types, chemical admixtures and mineral admixtures. Chemical admixtures contain maybe five types of chemical admixtures, and second, mineral admixtures for concrete. Mineral admixtures are finely divided materials which are added to the concrete in relatively large amounts, usually of the order of 20 to 100% by weight of Portland cement. Source of mineral admixtures. Mineral admixtures come from raw or calcined naturals mineral, industrial byproducts. Reasons for using mineral admixtures: reduce energy consumption in the manufacture of Portland cement, the ability of cement and concrete industries to consume millions of tons of industrial byproducts containing toxic metal would qualify these industries to be classified as environmentally friendly. The exploitation of the cementitious properties of mineral admixtures are used as a part partial replacement of cement can lead to considerable economic benefits, improved resistance to thermal cracking, and increase in unlimited strength of concrete. Classification of mineral admixture. Mineral admixtures may be classified as follows: pozzolanic and cementitious. ASIM specification C618 recognizes the following three classes of mineral admixtures. The first one is class N, raw or calcined natural pozzolanic such as clay and shales, tuffs and volcanic ashes. Class F, fly ash produced from burning anthracite and bituminous coal. Class C, ash normally produced from lignite or sub-bituminous coal which may contain analytical CaO higher than 10%. Silica fume. Production of silica fume. Silicon, ferrosilicon, or other alloys are produced in so-called submerged or electrical furnace. There are two types of electric furnaces. One is with heat recovery system and the other is without heat recovery system. Filler effect of silica fume. The small silica fume spheres act as fillers since they occupy some of the space between the relatively coarser cement grains which can be otherwise occupied by water. This results also in a denser matrix with a better gradation of fine particles. Selection of concrete admixtures. The quantity of admixtures to be used for specific application of admixtures are recommended by the manufacturers. For use in large construction projects, the quantity of the admixtures to be used shall be obtained from test reports for concrete mixed with admixtures at various percentage admixtures used. The selection of specific admixtures for use in concrete to alter properties of concrete should be selected carefully as per requirement of concrete works. After selecting the admixtures concrete, one should carefully choose the supplier with quality product, timely service, and competitive price. Concrete admixtures should be accepted with test certificate. manufacturing date, and its chemical composition should comply specifications given by the authorities.